All right, so when we talk about domain, doing this kind of composition here where G has to be inside of F, what we know is that we need to make sure that everything that that is in the domain of G, that all its outputs make something that is in the domain of F. So the way we're going to kind of do that is we're just going to actually do the composition. So just some sort of things that'll help you with make this a little easier is that we are going to search for the domain by doing the composition. So taking some of the thinking out of it. If we have something that ends up being rational, we are going to try not to eliminate common factors when we have rational expressions. There we go. Expressions. The one thing that kind of throws this off is that if you have a rational expression and then you have a common factor, so we saw that it makes, when we were doing polynomials, common factors cause wholes. A lot of times people learn to eliminate those common factors, just don't do it. So if you do a combination, try not to eliminate common factors if they exist, and just find the domain of the new function. So in this case, we have F composed of G, G is on the inside. We know that G is 2 of x plus 3. So what we're going to have here, if F is just the square root, or sorry, the fourth root of x, is the fourth root of 2x plus 3. So just something to kind of go back over again. So we did something like this very similar at the beginning of the semester. But let me expand on some, what should be recall, hopefully. So let's say we have something that is nth root of x. So something underneath that nth root. If n is even, then x would have to be greater than or equal to 0. So we saw that with a square root. That also applies to a fourth root, a sixth root, a eighth root, a 10th root, etc. If n was odd, so like third roots or third roots, fifth roots, seventh roots, things like that. In that case, x is all real numbers. So we are doing a fourth root of 2x plus 3, meaning this part inside of here has to be greater than or equal to 0. So if we just solve this for x, we're going to have 2x is greater than or equal to -3, because I subtract 3 from both sides. Then I divide both sides by 2. And we get x has to be greater than or equal to -3 over 2. So when we talk about the domain of this function here, the domain is all our x for which x is greater than or equal to -3/2. Or we could say it's everything from -infinity up to -3 over 2, union -3 over 2 to infinity. So we just basically just skip over that point at -3 over 2. So number 2 on your worksheet is, this is the case where we have radicals. So remember, what we have to do is we have to look at where our denominator is equal to 0, and that's what has to be removed from the domain. So we're doing domain of not radicals, I'm sorry, doing domains of rationals. Let's take a moment to do that and come back to finish this. Okay, so we have the functions. F is 3 over x minus 6, and g is x squared plus x. So for A, we're putting g on the inside because we're looking at F composed as g. So we're really looking at doing F of x squared plus x, which means then F is going to be 3 over, instead of just x minus 6 now, it's going to be x squared. I need a little bit more extra room there. It's going to be x squared plus x. So what that's going to leave me with, after dropping those parentheses, is this really just x squared plus x minus 6. So I have to look at where x squared plus x minus 6 is equal to 0. Well, you'll notice that this is something I can factor. I need two numbers that multiply to give me -6, but add to give me +1. Well, that'd just be x plus 3, x minus 2. So if I was to, like I said, take the denominator, solve it for 0, the two things that would make the bottom 0 would be -3 and +2. So my domain is x just as long as x isn't -3 or 2. Or we could say in interval notation, -infinity up to -3. Then we don't include the 3. We skip to the other side of 3 up to 2. Skip over the 2, and then we go 2 to infinity. So for the other case, we're going to have f is going to be inside of g because we got g composed of f. So basically, we're looking at g of 3 over x minus 6. So every place I have an x, something's in my way here, I'm going to put in a 3 for x minus 6. So what this is going to be is that this 2 distributes to the top and bottom, so we end up with 9 on top and x minus 6 squared on the bottom was 3 over x minus 6. So if you remember, we're going to have the multiplicity or this power. All it's telling me is how many times that 0 occurs. So I just have to worry about where does this equal 0? And technically, each one of these, we'd have to look at them. It's going to be both the same case, but any place where the denominator can be 0. What we're going to see is in both cases, we're just looking at x minus 6. So the one thing is going to get kicked out is 6. So my domain is going to be all x, with the exception that x cannot be 6. Or we'd say it's -infinity up to 6 union 6 to infinity.